Okay, in case you missed any of this, I want to go back over what we've been talking about in class recently about factoring quadratics. So quadratics are the equations that result from multiplying two binomials like these ones. So if we go and multiply 2x plus 3 and x times negative 4, or x and negative 4, we get 2x squared, negative 8x, 3x, and negative 12. So we can write that as 2x squared, and I'm going to do the plus 3x minus 8x minus 12, and then we would combine these two numbers and we would get 2x squared minus 5x minus 12. But I want to point out where this and this, these two pieces of this equation, come from. The 2x squared plus 3 comes from multiplying x times 2x plus 3. So see, we multiply x times 2x, we get 2x squared. We multiply x times 3, we get 3x. Likewise, the negative 8x minus 12 comes from multiplying negative 4 times 2x and negative 4 times 3. So negative 4 times 2x plus 3. So that's an important piece of information here. We're not going to really do anything with it just yet, but I want you to keep it in the back of your head where that, where each of these pieces of this expression come from. So a quadratic is a specific type of algebraic equation or expression in which the highest degree, and another word for degree, or a related word, is exponent. So the highest exponent is 2. So an example is this one that we just wrote here, 2x squared minus 5x minus 12. So to solve a quadratic by factoring, there's other ways to solve, which we'll go over later, but to solve a quadratic by factoring, you first have to get it back to its two binomial factors. Because from here, we know we can use the zero product property to solve. So the graph of a quadratic, just so that you know, is called a parabola. And a parabola can look vaguely like this, or an upside down version. Now it could be wider, it could be narrower, it could be shifted left or right, it could be shifted up or down, but these are the two basic shapes of a parabola. So I'm going to walk you through one method of factoring that I like to teach, one method that works in every single situation. So the method is to start by multiplying a and c, and you might be thinking, well, there is no a or c. Yes, there is. Okay, so we're going to take our original expression, 2x squared minus 5x minus 12, and when this is written in standard form like this, so x squared, x, and then no x at all, so descending order of the exponents, the first coefficient, so the 2 is a, the negative 5, or the second coefficient, is b, and then the constant here is c. So if I do a times c, what I'm doing is 2 times negative 12. So I get a times c is negative 24. So I want you to pause this for a second and then go and flip over to the back of your paper and find AC for each of the 4 problems. So A times C. So we're going to label A, B, and C, and then find A times C for each of the 4 problems on the back. Okay, so for the first one, we multiplied 2 times 21 and got 42. Over here, we got 5 times negative 18 is negative 90. If you notice, I added a 1 here in the middle. Remember, if there's no coefficients, then the coefficient is 1. So down here, problem number 3, I added a 1 in there in front of the x squared. So a is 1, c is 63, so a times c is 63. And then the same thing here, I added a 1. 1 times negative 18 is negative 18. So now what we're going to do is we're going to take AC, and we want to find the factors of AC that add up to B. So we want to find what multiplies to give us 24, but also adds to give us negative 5. So if you have a method, like if you're pretty good with positives and negatives, you can probably skip some of the factors, but don't hesitate to just list out all of the factors. I know that because this is negative, I need to multiply a positive times a negative. So I'm going to do positive 1 times negative 24. And when I add those together, I get negative 23. So that's not going to work. 2 goes into 24. I could also do a negative 20 or negative 1 times 24, sorry. And that gives me a positive 23, but that's not going to work either. So I go down to 2. So 2 times negative 12, if I add those, I get negative 10, so that doesn't work. And then negative 2 and positive 12, that's just going to give me positive 10. So I can do positive 3 and a negative 8. If I add those two together, there's my factors. I get a negative 5 when I add those together. Okay? So now go ahead and pause this, and you're going to go over to the back, and you're going to list out you're going to make your table of all of your things that add up, or I'm sorry, multiply to AC. So you wrote all those ACs on the back. You're going to find the things that multiply to give you AC, but also add to give you B. B is this middle coefficient here, and don't forget your positives and negatives. Okay, so I kind of shortened my list a little bit because I can use a little bit of my knowledge of products and sums to kind of not have to make quite as long a list just to save space. But the 42, I know that because 42 is positive, my factors have to have the same sign. So they have to be either positive, positive, or negative, negative. Now over here, I want them to add to positive 17. So if I'm looking at a combination of negative, negative, that's not going to add to a positive 17. So I know my factors over here have to be positive. So that way they would add up to a positive number. So I didn't bother with 1 and 42 because I know that's not going to add up to 17. So I jumped down to 2. 2 and 21 multiply to give me 42, but they don't add to 23. Or they add to 23, not to 17. So then down here, with 3 and 14, they multiply to 42, but they also add to 17. So those were my factors I want to use for that one. So I did the same thing over here with negative 90. I know that if it multiplies to be negative, I've got to have a positive and a negative. I know that if it adds to a negative, the negative has to be bigger. So I'm not going to I wasn't going to try like negative 3 and positive 30 because that would have not come out correctly. That actually should be negative 27. This would have come out to a positive 27, and that's not anywhere close to what I need. I also know that because it's coming out to negative 1, my two numbers have to be pretty close because like 5 and negative 6 add to negative 1. 7 and negative 8 add to negative 1. So what I was really looking for are two kind of consecutive numbers, 9 and 10, and then the 10 being bigger would have to be negative to make it negative 1. So I went through a list of a few things here to show you, but the 9 and 10, I was kind of able to reason that out a little bit just by looking at the numbers. But again, you could go down this list and do 1 times 90, or 1 times negative 90, negative 1 times 90, 2 times negative 45, negative 2 times 45. You could go down and make the list of all like 20 pairs if that's what you need to do. But if you can, use some of that knowledge of positives and negatives to, limit the amount of work that you have to do. The less work you have to do, the less likely you are to make mistakes. So down here, number 3, I actually made a mistake here. This should have been both, both positives, or both negatives, or both positives, because this is positive. But because this adds to a negative, then I've got to be dealing with negatives over here. So negative 3 and negative 21 make negative 24. Negative 7 and negative 9 add up to negative 16. So that's the numbers I want to use there. And then over here, to multiply to negative 18, I came to 2 and negative 9 that also add up to negative 7. So those are my factors over there on that side. So now we need to figure out what to do with them. So we're going to take our original expression, which was 2x squared minus 5x minus 12. And we're going to take this 3 and this 8. This negative 5 is no longer important. We don't need that. And cross it out, because I promise you, I have done dozens of these problems where I take this unnecessary number and I put it in here instead of what belongs there. Don't do that. Cross that number out. We're done with that number. So now I'm going to take this 3 and negative 8, and I'm going to rewrite minus 5x as plus 3x minus 8x. Just like this. So negative 5x is the same as positive 3 minus 8 x. So I just replaced this negative or minus 5x with something that was equivalent to it. And now I've rewritten my equation or my expression, and you see up here we're sort of on this same step. We started here and now we've gone back to this. So now I want you again to go ahead and pause this and go back to your problems on the back of this paper and find or rewrite your original expression, separating out those x terms. All right, so for number 1, 2x squared plus 17x plus 21 turns into 2x squared. I replace the 17x with 3x plus 14x. So this number and those two, or that term and those two terms, are equivalent to each other. And then bring down the plus 21. This is where I was telling you, you need to really cross out, well, if you're like me, you need to cross out this number, because instead of bringing down the number that belongs here, I oftentimes will do, okay, 3, 14, and 17. And I'll put the wrong number at the end. So just be careful if that's something you do, you're in good company. Just make sure that you're doing something to remind yourself not to use this number. So that's why I cross that number out when we're done with it. So over here, 5x squared plus 9x minus 10x minus 18. Now if you switch these two terms around, or these ones here, it's okay. Your work is going to come out a little bit different, but the procedure is still the same and the answer will be the same. And then down here, I have x squared minus 7x minus 9x plus 73. And then for number 4, I have x squared plus 2x minus 9x minus 18. So now, this is probably the toughest part of this whole thing, is factoring out the binomials here. So if you remember back up here, I showed you that these two terms right here were the result of taking x and multiplying it by 2x plus 3. And then these two terms here were the result of taking negative 4 and multiplying by 2x plus 3. So we're now going to go from this step back to that one. So the first thing I want to do, and I'm going to use a different color pen. Hopefully this doesn't bleed over too bad. I'm going to take my first group of things and my second group of things and put them in their own sets of parentheses. So this first group, I need to look at what they have in common that can be divided out. So what common factors do they have? And don't forget, x can be a factor. You can multiply by x. Likewise, you can divide by x. So 2 and 3 don't have any common factors. So the 2 and the 3 are going to stay. But I can divide each of these terms by x. So what's going to happen is the x is going to come out here to the front. And in my parentheses, I'm going to have now this x and this 2, or this squared, one of the x's we're multiplying gets eliminated because we've divided by x. So x times x divided by x is just x. So right here in this term, I have 2x. Now over here, when I divide x by itself, that reduces down to 1, so I'm left up with a 3 over here. Okay, now I want to do the same thing to this set of parentheses, but I'm not going to divide out an x because if you look, I don't have an x in both terms. So that's not a common factor of negative 8x and negative 12. Now, whatever this term is up here, positive or negative, that's the sign that you want to divide out. So we're going to divide out a negative of some kind. But I'm looking at 8 and 12, and the common factor, the greatest common factor that they have is negative, or is 4, so negative 4. So I'm going to divide out negative 4, so that goes outside the parentheses, like that. Negative 8 divided by negative 4 reduces down to a positive 2, and then negative 12 divided by negative 4 reduces down to a positive 3. So I have 2x plus 3 in this set of parentheses also. So if you did this correctly, what ends up in each set of parentheses should be the same. Now, if I had these two terms reversed, and I had negative 8x up here and 3x here, in my parentheses would be x minus 4, and I would have 2x and plus 3. So you may see that play out in your answers on the back, because if you reversed your middle terms, then yours will come out a little bit different from mine. But I'll let you know what would be correct. So I want you to go ahead and flip over again to the other side of this paper and do this next step, step 3, and see what you get. All right, so for this first problem, if we factor an x out of the first two terms, we're left with x on the outside of the parentheses and then 2x plus 3. So that's the result of dividing each of these terms by x. Over here, we divided each of these terms by 7, and we got 7 on the outside of the parentheses and then 2x plus 3. Now, if you had reversed the 3 and the 14, so if you had 2x squared plus 14x and then 3x plus 21, you would have gotten x plus 7 inside the parentheses and 2x and 3 on the outside. Over here, problem number 2, you should have gotten x on the outside and then 5x plus 9 on the inside minus 2 on the outside and 5x plus 9 on the inside. So notice my parentheses are the same. If you had switched the 9 and the negative 10 around, you would have gotten x minus 2 inside the parentheses and then 5x and plus 9 here. Sorry, that was the bell. Down here, x times x minus 7 minus 9 times x minus 7. If you flipped around the negative 7 and the negative 9, you would have gotten x minus 9 in the parentheses and then x and minus 7. And then over here, x times x plus 2 minus 9 times x plus 2. Again, if you had switched around the 2 and the negative 9, you would have gotten x minus 9 in the two sets of parentheses and then x and plus 2 on the outside. Okay, now the last thing that you're going to do is you're going to take what's in the parentheses and you're going to make it in a set of parentheses by itself. And then whatever's left, the x and the minus 4, you're going to put in its own parentheses. And then you use the zero product property to solve. So 2x plus 3 equals 0, x minus 4 equals 0. And so what I get is x equals negative 3 over 2, or x equals 4. So you know what I'm going to ask you to do next. Go ahead and flip this over, and I will come back and check your answers in a minute. Okay, so back here for number 1, we get x plus 7 and 2x plus 3. That results in solutions of x equals negative 7 or x equals negative 3 halves. For number 2, x minus 2 times 5x plus 9. The solutions there are 2 and negative 9 fifths. Please remember, don't change these to decimals. Here we get, for number 3, x minus 9 and x minus 7. The solutions there are x equals 9 and x equals 7. And then for number 4, x minus 9 times x plus 2, we get x equals 9 and x equals negative 2 as a solution. So if you have any questions about this, please feel free to ask. Have a good day.